Right, hello. So we're going to have a little look at trigonometry for our revision short today. So if we have a little think about what we do with trigonometry, we have got the ability to find missing sides and angles in right angle triangles now. You're going to need to know your exact trigonometric values, and we'll go through that as well today. Keywords that you need to know: trigonometry itself, right angle, opposite, adjacent, hypotenuse, angle and theta. So let's have a little look through here. Okay, so let's do the basics. So first thing you need to know is where the buttons on your calculator are. Okay, so on your Casio calculator you'll find them as shown. Okay, and if you have a little look above, it says sine to the -1 and cos to the -1 and tan to the -1. So you'll be using those buttons in their second mode as well. Okay. So if we have a little look at this, so what do we have to do when we're doing trigonometry? We're going to use SOHCAHTOA, so we're going to write SOHCAHTOA out. We're going to label our triangles. We're going to choose the triangle we're going to use by ticking what we want or what we need and what we've been given. We're going to write out our formula triangle and use it to substitute the values we've got into it. We're going to cover the thing that we want and do what's left, basically. So let's have a little example. So we've got triangle, we've got a side P we want to find, and we've got an angle and a side. So let's work out which sides we've got. So we've got the hypotenuse, longest side, we've got the adjacent, the side between the two angles. So if you write SOHCAHTOA out, so we've got SOHCAHTOA out there. So the triangle that has the adjacent and the hypotenuse involved is the cosine one. Okay, so if we now think about that, okay, so we're looking for the adjacent, so we're going to put our hand over the adjacent. There you go. And we've got the cosine of the angle times by the hypotenuse, so let's put that in there then. Okay, so now what we can do is we can put our values in. So substituting the values in, we're going to have P, the side we're looking for, which is the adjacent side, is equal to the cosine of 38 times by the hypotenuse, which is 8. Okay, and then the value we get when we type it into our calculator is going to be 6.3. Now you need to be really careful when you're typing it into your calculator. The cos, when you press cos, will open a bracket. It must be closed before you times it by 8. Okay, so it's going to open a bracket at the beginning just before the 30, the 3, and you need to close it just behind the 8. Okay, don't forget to do that. Right, another example. Let's have a look at this one. So we're looking for y this time. So we've got an angle and a side. Let's work out which sides we've got. We've definitely got a hypotenuse. Look, that's the longest side opposite the right angle. We've got an angle and we've got the side that is opposite the angle, so that's the opposite side. Okay, so if we write SOHCAHTOA out again, this time we've got hypotenuse and the opposite, so it's going to be the sine part of SOHCAHTOA. Okay, and what we're looking for is the hypotenuse, so our hand is going to go over the hypotenuse, the H. Okay, there you go. And when we've put our hand over the H, we're left with O on the top of a fraction and the sine of theta on the bottom. So let's pop that in. Okay, so we've got that fraction there. So let's redo it with the numbers that we know in. Okay, so we've got sine. We've got 5 is our opposite side, so I've replaced the O for opposite with 5. I've replaced the gap there with, instead of theta, I've put 41 in there. I've closed my brackets again, and then I can just pop that into my calculator. So I'm going to do that right now while we're sitting here. So I'm going to do 5 divided by the sine of 41. Remember to close my calculator's bracket. And that is going to give me 7.6. So let's have a look. Where is this? 7.6. There you go. And it's centimetres. Okay. Right. Moving on from there. Finding missing angles. So we're going to do exactly the same, apart from when we use our buttons, we're going to use our second function of our buttons. Okay. So everything stays the same as we had before, but we're going to use the inverse trig function, which is on your calculator the bit that's above the sine, the cosine and the tan. And if you imagine your inverse functions, if I told you to inverse a plus, you would take it away, you'd subtract it. If I told you to inverse a times, so multiplying, you would divide. If I asked you to inverse square root, you would square. And this is exactly the same. We're kind of undoing what's been done. We're doing the reverse, the inverse. Right, okay, so let's have a little look at this one. So we have got to find g this time, so we're going to label. So we've got our hypotenuse. We have got our adjacent side. Look, it's the one between the angle and the right angle. So we've got the adjacent. So when we write our SOHCAHTOA out, we've got theta, of course, the angle. Write our SOHCAHTOA out. So we are looking this time, we've got opposite. So we've got adjacent and hypotenuse. So it's going to be the cosine one again. This time we want the angle. So let's write that all out. So we need theta, we need the angle. So the cosine of theta is going to be, again, it's a fraction of the adjacent divided by the hypotenuse. So let's put that in. So adjacent divided by the hypotenuse. We now put our values in. So let's put those in. So we've got theta is equal to the cos to the minus 1. So we've used that second function. And if you're not quite sure about that, you press shift and the cos button. Okay, I'll put this over here. So it's shift and the cos button. Okay, and that will give you cos to the minus 1. Okay, so let's have a look at this. So we've got that going on there, and then when we put that into our calculator, again, remember to close your brackets. It's going to give us theta as 41.4. Okay, obviously you can pause the video and have a little look and try it on your calculators. Make sure you get the same as me. Okay. Right, so let's have a look at some problem solving with trigonometry or SOHCAHTOA. We're back to those boats and sailing east to H and going to B, the boy, and then going to the lighthouse. So let's rethink that through. There's my sketch again, look. And this time we want to make a sketch and we want to calculate the bearing of the harbour from the lighthouse. Okay, so let's have a think about that. So we want to work out the angle. We know that tan, so if we think about our sides, we've got tan is the opposite over the adjacent. So we're going to use that. So we've got 15, which is the opposite. The adjacent side there is 64. So we are looking at the moment for this angle here. Okay. So the angle at the lighthouse, the angle inside the triangle at the lighthouse. So we've got that as 66.9. Now, when we're talking bearings, we start with a north, don't we? So we've got to remember our north. So our north is basically that line that goes from the lighthouse to the buoy. And then the angle we're looking for is going clockwise from that line all the way round to the line from the lighthouse to the harbour. So the easiest way to do that is to do 360, take away 66.9, and we'll get that the angle, the bearing, is 293. Okay. All right, let's have a look at our house again. So this time we want to calculate the angle that the foot of the ladder makes with the ground. So where it says L on this one. I've seen these kind of questions come up in exam papers where they're talking about how safe a ladder is for a fireman to use and things like that. Okay. So we've got to label or think about what sides we've got. So we've got the hypotenuse again, which is the 12 foot. And we've got the opposite side this time. So we're going to be using sine this time, okay? So sine of L is the opposite divided by the hypotenuse, the same as our sine that we use normally. And you can write SOHCAHTOA out again as normal. You can work out which of the SOHCAHTOA ratios you're going to use, the triangles, and go from there. So that's fine, okay? Right, so the sine of 9.5 divided by 12, it's an angle, so it'd be sine to the minus 1 when you put it into your calculator, is 52 degrees. Right, okay, so we are going to look now at there's several different ways of working out our exact trig values, and they will come up on non-calculator papers. So I've got a right angle isosceles triangle, has two acute angles, both are 45, okay? You can see this is an isosceles triangle because it's got the two dashes on the two sides at the same length. And the two angles that are marked there have got to be 45. and you've got your 90 degrees, which obviously adds up to 180. So if we think about our SOHCAHTOA now, okay, so we are going to assume that the length of the two short sides are 1 unit each, okay? And then what we're going to do is we're going to think about using our Pythagoras theorem here, okay? So the hypotenuse, which is the one we don't know at the moment, that one is always the two short sides squared added together. So we have got 1 squared plus 1 squared, so that's going to be 2. So we're going to have the root of 2 as the length of our hypotenuse. So let's put that in, okay? So we now have all the angles we know and all the sides we know, and we can use this to work out our exact values for 45, okay? So let's think about our SOHCAHTOA. We've got sine, cos and tan of 45. So the SOHCAHTOA is the opposite divided by the hypotenuse, okay? So the sine of 45 is going to be 1 over root 2, because both of the short sides are 1, and our long side, our hypotenuse, is root 2. Our cos of 45 is going to be the same, isn't it? Because it's the adjacent divided by the hypotenuse, so that's going to be the same. And then our tangent is our opposite divided by our adjacent, if you think about your SOHCAHTOA. So that's 1 over 1, which is just going to be 1. Okay, so that's how we can work out the exact value of sine 45, cos 45 and tan 45. If we look at some other angles now that you need to know. So we've got an equilateral triangle. So that's where it's going to start. So that means we're going to put our side lengths as 2. And we know that an equilateral triangle has an angle of 60 degrees in each corner, okay? So we're going to think about that, and we're going to take out half of that triangle so that we have now got a hypotenuse of 2, and we've got one of the short sides as 1. So let's go back to our Pythagoras, okay? So we've cut the triangle in half. We've got an angle of 30 and an angle of 60 that we can do, and we're going to use our Pythagoras theorem to find out what that missing short side is. So we know that to find out that missing short side, we need the long side squared, take away the short side squared, whatever that is, we then square root. So we've got root 3, so let's put our root 3 in there. So we've now got, we know the 3 angles and we know the 3 sides of this particular triangle. And we can use that to find the sine, the cosine and the tan of 30, and the sine, the cosine and the tan of 60, okay? And hopefully you'll spot something interesting happening. So let's have a look at the sine of 30. So sine is opposite over hypotenuse. So opposite is 1 over 2. So that's a half. So that's nice and easy. The cosine of 30 is going to be the adjacent over the hypotenuse. So that's going to be root 3 over 2. Okay. And then the tan is the opposite over the adjacent. So our opposite is 1 and our adjacent is 3, root 3. Okay, so we've got our 30 degrees. Okay, so we can do those. The next one we can do is we can do the 60 degrees. So we do exactly the same with the 60 degrees. Sine, opposite over hypotenuse, root 3 over 2. Cos, exactly the same. It's adjacent over hypotenuse. So the adjacent is 1 over 2, so it's a half. And then the tan is opposite over adjacent, so that's root 3 over 1, which would just be root 3. Okay, so we've got that now. Right, so we can fill in those in there if you wanted to. So you can do a table and you can fill them all in. So I'm going to put those in. We've just worked those out. Okay, so you can either use your triangles to work out all of those, or you can make yourself a poster of these exact ones and commit them to memory, whichever way works for you. There is a third way, and this, I didn't learn this way at school, but someone has shown me since I've come into teaching it, and it's quite cool. And there's a Maths-Watch clip on it if you want as well. But it's to think about your hand. So you look at the palm of your hand, okay? And you think about your finger. So your thumb is your 0, your next finger, your index finger is 30, the middle finger is 45, then you've got 60, and then you've got 90. So what we can do then is basically what you do is you put your finger down on the one that you want to think about. Okay, so if we think about sin, okay, and I want to know what the sine of 30 is, we know what it is from our table. So I'm going to put my 30 finger down, and then I'm going to square root the fingers on the left, so that's 1 square rooted is just 1, and then divide it by 2, so that would be a half. Okay, so if we think about cos of 30, actually if we go back one slide, so we've got that. Okay, if we think about our cos of 30, so I'm going to put my 30 finger down again. Okay, so this time I've got 3 fingers on my right for my cos. So I'm going to do the root of 3, and I'm going to divide that by 2. So that's root 3 divided by 2. And if we look at all of those there, that's exactly what it is. And if we go back to our table, it's the same there. Okay, so that's how you use your hands, but you have to practice, and you have to keep practicing. Okay, so if you were doing the tan, you put your fingers down. So if it's a tan of 30, I put my 30 finger down and I divide the fingers on the left by the fingers on the right, and then I square root it. So I've got 1 divided by 3 square rooted. Okay, and if you look at the tan 30 there, that is exactly that. So you've got 1 divided by root of 3. And there we go. You got to remember to square root at the end. Okay, how you can use it on the calculator paper, sometimes they do this. They'll give you a question and they go, what is y? You can't use your calculator, so you have to go, oh, 60 degrees, let me think about that. And then you use your knowledge, so you can write things down. So if I'm thinking about my little triangle, I might go, my little triangle for 60, what was it? So I've got the hypotenuse and I've got the adjacent, so that is a cos. And cos is adjacent, so that was root 3 over 2, and then I could start thinking about it in that way. Okay, so you have to practice those. Right, I think that's the end of this. Yes, it is. So let's go back to there and stop this video.